Welcome to the video lecture series of Plus 1 Chemistry. Today we will discuss Chapter 12 Organic Chemistry, some basic principles and techniques. So here I am going to discuss about nucleophile and electrophile. So what are nucleophiles and what are electrophiles and what are the examples for nucleophile and electrophile in which kind of reactions they are participating. So these are the contents which I am going to express today. So first of all, we will see the difference between nucleophile and electrophile. Nucleophile, as the name indicates, it is electron rich and they are nucleus loving. So nucleophile means they are electron rich. They will have enough number of electrons and they are seeking for nucleus to attach with. They are usually negatively charged or neutral. So nucleophiles can be negatively charged or neutral. So as they have electrons in their hand, they will donate electrons. So these are the main points about nucleophiles. So out of the two categories of nucleophile, the first one is negatively charged species. Nucleophiles are negatively charged species, so X minus. Here X represents the halogens including fluorine, chlorine, etc. So if they have negative charge, which indicates that they have an extra pair of electron with them, so this electron pair can use in chemical reactions. Similarly, we have another example OH minus, hydroxide ion. They also have negative charge, which means that they have an extra electron. Then cyanide ion, Cn minus. So these are called a negatively charged nucleophilic species. And nucleophiles also will be neutral molecules. In the sense, NH3 or H2O. NH3 and H2O, as you know, NH3 is actually having a lone pair. So this lone pair will use in chemical reactions. So it can be act as a neutral nucleophile. Similarly, H2O. Oxygen will have two lone pairs. Okay, two lone pair. So these are having extra electrons as lone pairs in the atom. So these electron pairs, they can use it in chemical reactions. So these are neutral molecules act as nucleophiles. Now let us study about electrophiles. What are electrophiles? So when we look at this electrophiles, electrophile means electron deficient species. They don't have electron and say they are seeking for or attracting electrons. They can be positively charged. As you know, when an atom not having electron, it will get a positive charge. So usually electrophiles will be positively charged or it can be neutral. As they don't have electron, they usually attract electrons to complete the chemical reaction. So positively charged electrophiles, we have example Cl plus, and this is called a chloronium ion. Chloronium ion, as you know, it belongs to chlorine, belongs to halogen family. Okay, if it is having a negative charge, we can call it as nucleophile. But if chlorine has a positive charge, which means that it is not having electron in their octet. Okay, so this is called chloronium ion. Chloronium. Chloronium. Chloronium ion, which can act as a positive electrophile. Okay, and the positive sign indicates that this are having electron. Then CH3 plus, carbon with the positive charge, we call it as carbonium ion. This is methyl carbonium ion due to the positive charge, which means it is deficient of electron, so that it can act as positive electrophile. Then NO2, nitronium ion, NO plus, NO2 plus. Okay, again positive charge indicates that it's not having any electron. Now neutral nucleophile electrophiles are there. So BF3, then aluminum chloride, AlCl3. These are actually boron, aluminum comes in the 13th group in the periodic table. They itself, these atoms represent electron deficient atoms. As they belong to 13th group, they have 6 electrons in their octet. So they need 2 more electrons to complete the octet. So they have only 6 electrons in their valence shell. Okay, so as you know, as per according to octet rule, they need 8 electrons. Okay, so these atoms, boron, aluminum, 13th group atoms, we say they are electron deficient atoms. So due to their electron deficiency in the structure itself, okay, so these electrophiles we say neutral electrophiles because they have only 6 electrons in their valence shell. Okay. Now, so BF3 and AlCl3 can be act as neutral electrophiles. So these are the examples for electrophiles. Now, if we look at a reaction, chemical reaction taking place between an electrophile and nucleophile, okay, so how does it represent? So look at the reaction written here. E represent here. E means it's an electrophile, okay. This E is electrophile and Nu represent nucleophile. So nucleophile, as you know, they have an additional electron pair. Okay, when a reaction takes place, this electron pair move towards the electrophile because they don't have electrons. So electron pair from the nucleophile move towards the electrophile, and there will be a bond forming in between electrophile and the nucleophiles. There is a bond between electrophile and nucleophile. This is a common reaction happening in chemical reactions. So if you are taking a particular example like CH3X, CH3X is called a alkyl halide. It is methyl halide. Okay, X represents halogen, chlorine, bromine, any atom it can be. So the bond sharing between carbon and halogen. Okay, so actually it represents an electron pair. This electron pair move towards the halogen atom because halogens are more electronegative than carbon. What is meant by electronegativity? Electronegativity means which atom has the tendency to accept the electron pair towards it. So when you compare halogens with the carbon, carbon comes to the 14th group and halogen comes to the 17th group. So halogens will have more tendency to accept the electron pair. So these electron pair move towards the halogen atom and makes halogen partially negatively charged. We represent it as delta negative. So delta negative, partial negative charge, and carbon correspondingly it becomes partial positive charge. Okay. So when this halogen acquires electron, it leaves as X, X minus. Halogen leaves with that extra electron pair. Okay, that's why we put a negative charge over here. And then the remaining part is CH3, which will have a positive charge. So then it acts as an electrophile. And the attacking nucleophile, this is attacking nucleophile. So with its electron pair, this nucleophile attached to the carbon, which is positively charged, which is ready to accept the electron pair and forms a bond. So we will get a bond in between CH3, then Nu. Nu means the nucleophile is attacking. So this is general reaction, usually representing electrophile and nucleophile in a general chemical reaction. Now we'll see some examples from the textbook. So we have some some problems. Problem 12.11, 12.12, and 12.13 in the textbook. So this is a question. Using curved arrow notation, show the formation of reactive intermediates when the following covalent bonds undergo heterolytic cleavage. Heterolytic cleavage means it usually forms the formation. It usually leads to the formation of free radicals or carbonium ions, carbanions, etc., etc. So the first one is CH3 HCS3, CH3 SCS3. So this is actually S means sulfur. So when you have a reaction like this, okay, I'm writing separately CH3 SCH3. So how does a heterolytic cleavage happens here is this carbon, you need to compare carbon with the sulfur. So these are the atoms which forms sharing an electron pair in between here, okay. So carbon and the sulfur shares one electron, that's why one bond formed here. And you have to compare the electronegativity of carbon and with the sulfur. Carbon belongs to 14th group and sulfur belongs to 16th group. Okay, so sulfur will have 6 electron pairs in their surrounding, in their valence shell. So sulfur need only 2 more electrons to complete the octet. What I'm trying to say that sulfur is more electronegative than carbon, so that the electron pair will shift towards sulfur, making sulfur negatively charged because the electron pairs are shifting towards sulfur, and carbon is not feeling any electron pair, so carbon will get positive charge. Okay, so CH3 plus and SCH3 minus. So why S will have this negative charge? Because sulfur acquires the electron pair due to high electronegativity compared to carbon. So sulfur will get that electron pair and it gets negatively charged. Now we have the second example, CH3CN. So here you have to check the CH3 group with the CN group. So here both are carbon atoms. CH3, I am writing it this way. CH3, this H I'm writing on the back side of the carbon. Okay, it's easy for you to identify the bond. CH3CN. So in between the bond, see here this is carbon and this also carbon. But which are the groups or atoms attached to that carbon? So carbon here it is attached to nitrogen, and here in this side it is attached to hydrogen. So cyanide group and this methyl group. Cyanide group is more electronegative than this methyl group. Understood? Because nitrogen is more like electronegative than this hydrogen. Okay. So this cyanide group will attract electron pairs towards it. So electron pairs. Electron from the bond is shifted more towards the cyanide group, making the cyanide group negatively charged and the carbon with the positive charge. Now CH3 and Cu. So here CH3 we are comparing with the Cu. Cu is metal. Okay. So we know metals are electropositive. So electron pair will shift towards carbon. Cu metal is less electronegative. Actually it is electropositive. So the electron pair is more shift towards carbon and making carbon negatively charged. So this is carbanion. CH3 plus and CH3 minus, sorry, and Cu with acquiring a positive charge. So this is the problem 12.1, and now we have next example as that is problem 12.12. Giving justification, categorize the following molecules or ions as nucleophile or electrophile. So we have SH minus. So what is nucleophile? So wherever we have nucleophile, okay, this is nucleophile and I am writing electrophile here. Electrophiles usually will have either it will have a positive charge or it can be neutral. Nucleophiles usually will have a negative charge. Okay, this is an easy way to represent it. Whenever you are getting some kind of species like this, okay, so you have to check which one will have the negative charge and which one will have the positive charge. So that's the direct hint. We can classify, we can use it for classifying electrophile and nucleophile. So SH minus. So this SH minus is actually nucleophile. Now BF3. BF3 is electron deficient molecule, as we told in the previous sometimes before BF3. Electron deficiency comes under electrophilic species. C2H5O minus. Thus there is one negative charge. So it comes under the category nucleophile C2H5O minus. Now CH3 thrice N. Next question. CH3 thrice N. Okay. So due to this extra lone pair, N will have lone pair, okay, this extra electron, it comes under the category of nucleophiles. So that is CH3 thrice N. So N will have lone pair, so it is nucleophile. And NH2 minus with an electron pair, that is again nucleophile. NH2 and H2 with an negative charge. So there is lone pair and as well as negative charge. So it can definitely act as nucleophile. Cl plus, we already told about it. It is chloronium ion. There is no electron deficiency in chlorine atom. Now there is an ion, positively charged ion. So it is definitely electrophile. And CH3C double bond O. So here there is a positive charge. Okay. So due to the presence of that positive charge, this carbon will have positive charge. So this is definitely an electrophile. Yes, it comes under category of electrophile. Then NH2 we already told, then NO2 plus. So due to this positive charge, it is again electrophile. NO2 plus. Okay. What is the reason? Nucleophiles, all nucleophiles will have either the negative charge or they have an unshared pair of electron. Lone pair, we call it as lone pair. That's why they are nucleophiles. Why these all are electrophiles? They will have positive charge or they are electron deficient species like boron or aluminum, etc. Now, next question 12.13. Identify the electrophilic center in the following: CH3CHO. First question CH3CHO. How do we identify the electrophilic center? So, this is the way you have to write CH3, then C, this is CH, double bond O. So, when you have a double bond or triple bond in carbon, okay, so take that carbon with the heteroatom. Here the atom is oxygen. So, you have to compare this carbon with this oxygen because they have say their electronegativity will be different. They don't have the same electronegativity. So oxygen is more electronegative than carbon. So electron pairs will shift towards oxygen. Okay, and making oxygen negatively charged and the carbon positively charged. Okay, now due to that shifting, oxygen will get a negative charge and carbon will get a positive charge. So this is the electrophilic center. So carbon is the electrophilic center as they have partial positive charge due to the polarity. Polarity means change in charges. Due to the shifting of the electron, oxygen gets a negative charge and the carbon gets a positive charge. Now this becomes a polar bond. Due to this charge difference, carbon can act as the electrophilic center. Now next question is CH3CN. CH3 CH3 CN. But the hydrogen I am writing here is CH3 C triple bonded. Okay. As you know, we are comparing carbon with this carbon with this nitrogen. Why? Because they have the triple bond, and secondly these two atoms will have a high electronegativity difference. So what will happen here? The double bond, the electron in the triple bond, sorry, triple bond, okay, this will shift towards nitrogen and making it negatively charged and the carbon positively charged. So what will happen? Carbon acquires a partial positive charge and the nitrogen gets a negative charge. So this will have negative charge due to the shifting of electron and carbon will get positive charge. So then it can act as electrophilic center. Okay. Now we have the last example CH3I. CH3I. Why they have given the I? I comes in the halogen group CH3I. So what will happen here? This electron pair will shift towards iodine because iodine is more. Iodine all comes in the halogens group. Okay. So iodine will get a negative charge and carbon will acquire a positive charge. Understood? Now, this due to this positive charge, okay, and this negative charge, the bond we say the polar bond, and the carbon with the positive charge can act as the electrophilic center. So these are the three questions we have answered from the textbook. So today we discussed about what is electrophile and nucleophile, and we studied some examples also for electrophile and nucleophile. Okay. You know, electrophile means they are electron deficient species. So they want electron to complete their octet and they can be positive charge or neutral. Usually they attract electrons. We have examples Cl plus, which is called a chloronium ion, and carbon with a positive charge is called carbonium ions. Okay, and the nitronium NO2 plus. So neutral we have BF3 and AlCl3. Nucleophiles are electron rich species, so they have electrons. So they are seeking or attracting nucleus to attach with it. Or usually they donate electrons. So what is the easy way to find an nucleophile? Either they have a lone pair, or they have a negative charge in the species given. Yes, students, I'm thinking that you understood the topic. Okay, if you have any doubt, please comment. Next class will be coming with another video. Thanks for watching the video. Bye bye. See you.